Hello again. We have already taken an introductory section to the subtopic motion along inclined plane. A number of forces, much more than what we have contained or displayed on this diagram, can actually act on the block, and this depends on the information supplied in the question. Now let's consider the plane below. Now the forces acting on the body are: one, the weight of the body, which acts vertically downwards; two, F and mg sine theta, which acts parallel or along the plane; and thirdly, we have R and mg theta, which act perpendicular. We can see that these two forces act perpendicularly, that is, at right angles to the plane. The force F has a tendency to hold the body at rest. That is, this force F acting on this body in the upward direction has the tendency to hold the body at rest. And if that be the case, the body is on the verge of moving downwards, and that's why this mg sine theta will come to play. It can also move it parallel, horizontally, or at an angle up the plane. We'll get to see more of this in the example presented in this video. Now, since there isn't motion perpendicularly to the plane, then the net perpendicular force is 0. You can see that no force is pulling this body off the plane. Motion only takes place along or parallel to the plane. So the net force in the perpendicular direction would be 0, and that is why these two forces would cancel out, which means that they are actually equal in any possible way, that is vice versa. We can write this as mg cos theta equals to r. And when we take the difference between these two, we get 0, which means that the positive difference, which is the net perpendicular force, must be 0 in this case. Now, please note R changes its value when the force acts horizontally or at an angle to the plane. Frictional force is ignored when the plane is considered to be smooth. Now let us take some examples. The very first one. Now, a body of mass 8 kg placed on a smooth plane inclined at an angle 30 degrees to the horizontal is acted upon by an upward force of magnitude 550 newtons at an angle 45 degrees to the line of greatest slope. Find, 1, the acceleration of the body. We are asked to take acceleration due to gravity as 10 meters per second square. We are going to present, the solution will be presented on the white board about to be displayed. Now the solution. Now we have a number of forces acting on this body as displayed on the diagram here. Now I want to quickly make emphasis on the weight of the body and as well the upward force acting on this body. The weight of this body is acting vertically downwards and at an angle of 90 degrees to the horizontal and not to the plane, but as components acting perpendicularly to the plane, which is this, and also acting parallel or along the plane, which is this very one. Likewise, the force of 50 Newton. This force of 50 Newton is acting on this body at an angle of 45 degrees. So it has components perpendicular to the plane, which is this very one, and components parallel or along the plane, which is this one. I want to believe by now that we know why the component of both the weight of the body and the force, the upward force acting on this body. Now, a quick reminder on that again. Now, the side adjacent to the angle 45 degrees here is always cos, and the side opposite to the angle 45 degrees is always sine. And likewise likewise the one for the weight, the side adjacent to the angle 30 degrees is always cos. The adjacent side is always cos, and the the opposite side is always sine. Please note that we are only told that the force acts on the body in an upward direction, and not that the force moves this body up the plane. So either this body moves up or down the plane now depends on the greater force between the forces acting parallel or along the plane, which are this and this. Now, if we quickly confirm the values for these two forces, we will see that this force here, this hg sine 30 degrees, is actually greater than this one, and that indicates that this block is being pulled downwards. Now, since motion takes place only along or parallel to the plane, motion takes place only along or parallel to the plane, then all the forces acting perpendicularly to this plane are balanced and as such are equal, which means that the net perpendicular force is zero, because motion only takes place along or parallel to this plane. And that is the requirement for the second question, which is to find the magnitude of the normal reaction. Now, since motion is only along the plane or parallel to the plane, the net or resultant downward force will be the difference between the greater force and the smaller force, and that is why we have this as 8 sine 30 degrees minus 50 cos 45 degrees, and that equals to 8 since there is a resultant force, and that actually means that the body accelerates downward. So we are going to equate this resultant force to 8a, which is actually from Newton's second law of motion. So when we continue with this, sine 30 is 1 over 2, which is half, and cos 45 is root 2 over 2. When we continue with this, we will see that our A approximately gives 0.58 meters per second, 0.58 meter per second square. Now to the second question of the first part. Since there is no net perpendicular force, so the forces acting perpendicularly to the plane are all equal. So all the ones acting perpendicularly upward are r and 50 sine 45 degrees. The sum of these two must be equal to the downward perpendicular force, which is hg cos theta. And when we go on with this, sine 45 is root 2 over 2, whilst cos 30 is root 3 over 2. Going with this, we have our final answer, which is the normal reaction, to be approximately equals to 34 newtons. Now, the second question, the first question of Number 2, what force parallel to the plane is required? A, to hold the mass at rest. So this is the very first part of question 2. Since the block is held at rest, it is on the verge of sliding down. Thus, all forces are balanced and the frictional force, which in this case is the static frictional force, would operate at its maximum possible value, which equals the product of mu and the normal reaction. Since the forces balanced out, it means that the perpendicular forces are equal as well as the parallel forces. So if that be the case, our R should be equal to this, which is 10J cos 60 degrees, and that will give us 49 newtons. And the forces, the parallel forces, are also equal, which means the sum of these two must be equal to this very one here, and that is what we have presented in this solution. And when we go on with that, we have our P to be approximately equal to 65 newtons. Now, for the second part of question 2, since the block is just to be moved up the plane, it is still at rest at this point, and then all the forces acting on this body are balanced, and the static frictional force would operate at its maximum possible value, which equals 19.6 newtons, since our R is 49 newtons. Going on with this solution, we'll see that our P will be 104 newtons. Please note that the static frictional force would go in this direction, in this downward direction, since the body is just about to be moved up the plane. Now to the last question, which is question 2C. If P is the force that will just make it move up the plane, then this P has two components, which are these two. Now, since this force will just make this object, this body, move up the plane, then it is still at rest at this point, and that makes all the forces to be balanced. That is, the perpendicular forces are balanced. That is, these two forces are equal. This R and this R is equal to the sum of these two forces, since they are acting perpendicularly downwards. And the parallel forces are also equal, which means that the sum of these two forces is equal to P cos 60 degrees. And that is exactly what we have contained in the solution. Going further with the solution, then we have our P to be approximately equal to, say, 671 newtons, and that ends it on the worked examples. There is an assignment given here. So this is the assignment given for this purpose, for us to get ourselves refreshed with, and it is to be submitted latest by 9 a.m. on the 24th August 2020, exactly on Monday. Thank you for this session. God bless.